Okay, today we're going to start talking about right triangle trigonometry. So you guys have done trig in Algebra 1, Geometry, in my college prep Algebra 2. We did this for ACT, but what you're going to find is that there are actually 6 trig functions, not just 3. So what should we know? We should know when we have a triangle that is a right triangle. The new thing here is this is a theta, Theta. You're going to see that for an angle lots of times. So we're talking about the angles. If we look at that angle, that side is opposite because it is across from the angle. That side is the adjacent, which means next to, because it's next to the angle. Hypotenuse is always the side that is across from the right angle. I know people will say it's the longest side, it's the slanted side. The best definition, it's across from the right angle. So what do we already know? We know that if we have the word SOHCAHTOA, sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So the word SOHCAHTOA has O, H, and A. O, H, and A. O is opposite, H is hypotenuse, A is adjacent. So what we knew before, sine, cosine, tangent. If we had this triangle, if I said what is the sine of theta, I look at theta, sine, opposite hypotenuse. So opposite hypotenuse, B over C. Cosine, adjacent over hypotenuse. Adjacent, hypotenuse, A over C. Tangent, opposite adjacent. So opposite adjacent, B over A. What we have now are these 3 new functions. This is cosecant, this is secant, this is cotangent. Now, you want to remember that the cosecant goes with the sine, the secant goes with the cosine, the cotangent goes with the tangent. I always say like the co doesn't go with the co. That does not go with that. Now, when I say it goes with it, if you find the sine of theta, the cosecant of theta is going to be the reciprocal. So it's going to be C over B. Now, you could say that's the hypotenuse over the opposite, but it's really just easier to find this and then flip it. So the secant is C over A, which would be the hypotenuse over the adjacent. Cotangent, instead of opposite over adjacent, it's adjacent over opposite. So we have 6 trig functions. Now, in doing SOHCAHTOA, the other thing that we should know, I hope we all know, Pythagorean theorem. If I have a right triangle, the legs are A and B, the hypotenuse is C, A squared plus B squared equals C squared. So we should have knowledge of that Pythagorean theorem. So what we're going to be asked to do to start is just evaluate 6 trig functions. So if I gave you a triangle, and it's sort of like I always say, just keep that word there so you know SOHCAHTOA. If I gave you, let's just really start basic. Basic would be everything's plugged in for you. The sides are there. That's 8, that's 15, That's 17. Now, if I said evaluate the 6 trig functions, you know you're going to have sine, cos, tan, cosecant, secant, cotangent. So you find the sine. And these are theta. I'm just being sort of lazy and not writing it in. Sine is opposite over hypotenuse. So I look at where theta is. That's theta. Theta can be here or there, wherever you see it. So if that's theta and I need opposite over hypotenuse, that is across from opposite. That is the hypotenuse across from the 90-degree angle. So sine is 8 over 17. Well, what does that mean cosecant is? 17 over 8. Cosine, adjacent over hypotenuse. Next to over hypotenuse, 15 over 17. So that means the secant is 17 over 15. Tangent, opposite over adjacent. Opposite over adjacent. So 8 over 15, which then means the cotangent is 15 over 8. So pretty basic if the numbers are filled in. So what do I do if they're not filled in? So I ask the same question and I give a triangle and I'm going to put theta down here because it doesn't matter where I put it. And I tell you that this is 3 and this is 4. Well, if you go and say, oh, I got to find the sine of theta. There's theta, opposite over hypotenuse. I don't have the hypotenuse. So that means I've got to do, my legs are A and B in Pythagorean theorem. 3 squared plus 4 squared equals c squared. Now, I know a lot of you do know the 3, 4, 5 triangle, but if you don't, you square. So that's going to be 9 plus 16. 25 equals c squared. You square root it. That means c is 5. So now, what's the sine? Opposite over hypotenuse. What's the cosine? Adjacent over hypotenuse. What's the tangent? Opposite over adjacent. What am I going to do to find the other 3? Flip them. 5 over 4, 5 over 3, 3 over 4. Okay? Now, other question comes in. That was a nice missing side. So if I change this and I make this triangle, let's say I give you this. This is theta. This is 10. And this is 15. So when I do these trig functions, I'm always going to look at that angle. But before I can do anything, I need that side. That's a leg. So a squared plus b squared equals c squared. I square them. So I have that. Now I have to get b squared on the side by itself. Subtract 100. I have b squared equals 125. I square root. Now, you do not use decimals. A standardized test is never going to use decimals. Got to reduce that radical. What perfect square goes into 125? 25. So that is 25 times 5, which is 5 radical 5. So now I have that side. Now, when I go and do my trig functions, you can't have a radical in the bottom. So you have to make sure you rationalize your denominator. So sine 5 radical 5, because that's opposite over hypotenuse. Now, you always want to reduce that fraction if you can also. So the radical stays by itself, but 5/15 is 1/3. So that is radical 5 over 3, or 1 radical 5 over 3. So now what is cosecant? You want to flip the thing that you've reduced. So that's going to be 3 over radical 5. You can't have a radical in the bottom. You got to multiply by stuff that we did at the beginning of the year. Well, 3 times radical 5 is 3 radical 5. Radical 5 times radical 5 is radical 25, which really is just 5. Cosine, adjacent over hypotenuse. 10 over 15, you reduce that fraction 2/3. So what's secant? 3/2. Tangent, opposite over adjacent. 5 radical 5 over 10. 5/10 is 1/2. So that's going to be radical 5 over 2, or 1 radical 5 over 2. So then cotangent, flip that, 2 over radical 5. Can't have that radical. So multiply it by itself. Whatever you do to the bottom, you do to the top. 2 radical 5 over 5. So you should not have a radical in the denominator, and you should have a reduced fraction. So the only other question that really would be asked is if I said to you, the cosine of theta is 6/7. Find the sine. Well, what you want to do is draw a triangle. So if the cosine is 6/7, you draw a right triangle, you put theta somewhere, and then you label it. Cosine is adjacent over hypotenuse. So adjacent to that angle would be 6. Hypotenuse would be 7. Now, if I need the sine, I need opposite over hypotenuse. I don't have that. So I have to do Pythagorean theorem. I'd get a squared plus 36 equals 49. Subtract 36. A squared equals 13. You got the square root of 13. It can't reduce. It's the square root of 13. So what is the sine of theta? Opposite over hypotenuse, square root of 13 over 7. Okay? If I asked you for all 5, or all 5 remaining, if I said the secant is 2, find the other 5. Well, you want to think of that as 2 over 1. Well, if the secant is 2 over 1, you know the cosine is 1/2. Now, how are you going to find cosecant, sine, cotangent, and tangent? I would use this, the one you're most familiar with. You draw your triangle, you put a theta. Cosine is adjacent over hypotenuse, 1 over 2. You do the math. You find that that's 1 squared plus b squared equals 2 squared. You're going to get square root of 3. Fill everything in. So that is finding trig ratios. There are 6. With the delta math assignment I gave, most of this is probably more work than you're really even going to be asked to do on that. But you should know those 6 trig functions. All righty.